This video is for my 7th grade math class and is over lesson 24, Reducing Fractions, Part 2. So ladies and gentlemen, this lesson here really is an option for reducing fractions. It's not necessarily required, but these can be just different ways of approaching reducing a fraction. So let's take a look. Our first method for reducing a fraction is going to be by using prime factorization. So if I have 72 over 96, and really these should be full-size numbers filling the whole space, but I did the best I could on the computer. You'll have to forgive me a little bit. But 72 over 96. So what I'm going to do is I'm going to prime factorize each of these, and I'm going to start with 72. And I like 72 with the factor tree, because right away with 72, I know that 72 is 8 times 9. Now remember, this is prime factorization, so I'm going to keep splitting this apart until I get down to primes. So 8, I know, is really 2 times 4. And remember, it's got to be times. If you put 4 and 4, that'd be wrong because we're multiplying. 2 times 4 is 8. Well, 2 is prime. I'm going to put a box around that just to say that that branch is done. So it's not my answer. That's why I'm not using a circle. And then 4 splits up into 2 times 2, which are both prime. I'm going to put a box around them. So far I have 3 2's. Over here, 9 we know is 3 times 3, which of course both of those are prime as well. So up top, what I'm going to do is I'm going to do equals, and I'm going to write a big long fraction bar, and I'm going to write this out. And I'm going to actually write it out, all its numbers, no exponents here. So putting them in order, because that's what we do for prime factorization, I've got 2 times 2 times 2. That's my 3 2's there. And then I have a 3 and a 3. 2 times 2 times 2 times 3 times 3. There they all are. For 96, I'm going to prime factorize this actually using division by primes, because maybe we don't have something memorized that this times this equals 96. And so it could be helpful here to actually do some division. Now remember, the rule though for division by primes is just like the name suggests. You must divide by primes. This is not optional. You must divide by primes. So we think through our primes: 2, 3, 5, 7, 11, 13. What do we think goes into 96? And there actually should be 2 of them that pop out right away. One of them that should pop out is 2, because it's an even number. The other one that should pop out is 3, because both 9 and 6 are divisible by 3. So I'm actually going to go with 3. And we're going to do this division, but it's upside down. So we're going to say 3 goes into 9 3 times, and it goes in perfectly. There's nothing left over. So then 3 goes into 6 2 times, perfectly, evenly, nothing left over. So it's 32. All right, now 32 is not prime, so we're going to do another division box there. And at this point, I think I'm going to take advantage of the fact that this is even. And so 2 goes into 3 once, which if we think about that, 1 times 2 would be 2, subtract, we'd have 1 left over. So I'm going to take the 1 left over and put it over here to make that a 12. This is called short division. 12 then goes, or 2 goes into 12 then 6 times evenly, and there we are. Oh, 16, we know 16. 16 should make this real easy now, because we know that 2 goes into 16 8 times. We know that 2 goes into 8 4 times, and we know that 2 goes into 4 2 times. And now I've got all primes on the outside. So put these primes together, and we have our prime factorization for 96. So 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5 2's, and a single 3. Now, once we have these 2 prime factorizations, we can go ahead and reduce. Now, if you have something over itself, well, that's always going to be 1. These are going to go into each other once. So they turn into 1's. I have another pair of 2 on top and bottom that turn into 1's. Another pair of 2's on top and bottom that'll go and become 1's. Now, can I make these 2 a pair and turn them into 1's? Hopefully you've just said no. And the reason, of course, is because they're both in the denominator. In order to reduce, it must be something from the numerator with something in the denominator. So these 2's cannot reduce with each other. These 3's cannot reduce with each other. But this 3 and that 3 can reduce because this 3's on top, that 3's on bottom. Numerator, denominator. This becomes a 1, that becomes a 1 because they're the same number. And now ignore the 1's. What's left over? I got a 3 up top. I got a 2 times 2 on bottom. Any more reducing there? No. So multiply what's left. 1 times 1 times 1 times 3 times 1 is 3. And on bottom, 1 times 1 times 1 times 2, so that's 2, times 2, that's 4, times 1 is 4. 72 over 96 is 3/4. And we'll circle our answer. And that is reducing using prime factorization. So, we can also reduce using the GCF. So if I look for the GCF of 72 and 96, first I would have copied my fraction, then I've got that down. I'm going to look for this answer. So remember, to find the GCF, we're actually going to start backwards. So we're going to start with the factors. I want to find the factors of each number. So 72, and then we have the factors, 1 and 72. And then we start counting. Does 2 go into 72? Yes, it does, 36 times. Does 3 go into 72? Yes, actually, 3 days, 3 times 24 is 72 hours. 3 days is 72 hours. Does 4 go into 72? That one might be a little harder to think through. Sometimes it can be helpful to look for some point of reference, like 80. We know that 4 goes into 80, so can we count backwards by 4s to 72? Or we know 4 goes into 60, can we count forward up to 70? And if I do 80, I can count back to 76, and then back to 72. So I do know it goes in. 4 goes into 80 20 times, but then we took away 2 groups. So 2 away from 20 is 18. 5 does not go into 72. We know that because it doesn't end in a 0 or a 5. 6 we do know because remember, our divisibility test for 6 says if 2 works and 3 works, then we know 6 works. So now it's just a matter of figuring out how many times does 6 go in. Well, we know 6 goes into 60 10 times. We know it goes into 66 11 times. So it must go into 72 12 times. Does 7 go into 72? No, because we know 7 times 10 is 70. That's just too close. We're not going to get another group of 7 in there. So 8, yes, we know 8 times 9 is 72. And then, 9 is already there. So 72 actually has a lot of factors. 72 actually has, 12 factors? So now I'm going to look for the factors of 96. So for the factors of 96, we start with the factors, 1 and 96, and then we count. 2 we know goes into 96, it's even, so it goes in 48 times. 3, we just did that up here, we know 3 goes in 32 times. 4, well remember it's 4 groups of 25 is 100, and this is just one group of 4 less than that, so 1 less than 25 is 24. 5 does not because it doesn't end in a 0 or 5. 6 does because we know 2 and 3 both work. So 6 times, that one might be a little harder to figure out, but if we work it out, eventually we'll figure out that this is 16. 7 does not. So now don't just say no when you're doing the homework. Make sure you actually check, but it doesn't. 8 does. It's actually 8 times 12. 9 we know does not because 9 times 10 is 90, but 9 times 11 is 99. That skips right over 96. We know 10 doesn't because it doesn't end in a 0. And then we know 11 doesn't because it's not a double digit, same digit. So 99, 88, 77. So 11's out, and well, 12's already there. So we found all the factors. Now we're going to figure out what they have in common. And for this, remember, ladies and gentlemen, we're going to use boxes, kind of like we did up here because these aren't our answers. The boxes just help draw our attention to things. So I'm going to just go around one of these. I'm not going to go around both of them. I don't have to. I'm just going to go around one of them. And I'm going to ask myself, do they both have 1s? If they do, I'm going to put a box around both of them. Do they both have 2s? Yes, they do. But they both have 3s? Yep. Do they both have 4s? Yes, they do. Do they both have 6s? Yep, good so far. Do they both have 8s? Yep. Do they both have 9s? Well, no, because 9 would be in between the 8 and the 12, and it's not there, so no 9s. Do they both have 12s? Well, yes, they do. Do they both have 18s? No, it would have to be in between the 16 and the 24, so no 18s. Do they both have 24s? Yeah, they do. Do they both have 36s? Nope. And do they both have 72s? No. So what we have boxed right here now are the common factors. So originally we found the factors, now we have the common factors, and so we're left with just choosing the greatest. So what's the greatest thing there we boxed? 24. So 24 is the GCF. We can reduce this completely by dividing it by 24 over 24. So a form of 1 using the GCF. Well, we've already got the work for this. We know that 24 times 3 is 72. So 72 divided by 24 must be that 3. And we know 24 times 4 is 96. So that must be the 4. And once again, we find out that 72 over 96 is 3/4. So those are both methods of reducing a fraction. These are optional unless directions tell you to do them. So if the directions tell you, you must follow the directions, but otherwise they're optional. So ladies and gentlemen, we're going to take a look at another way of reducing. This time is a skill called what I call reducing before multiplying. Now you'll hear about this in other classes. It may come with other names like cross reducing, cross canceling, cross dividing. It usually has some sort of cross in it. That's not the name I choose to call it. I choose to call it reducing before multiplying, and the point here is it has to be before multiplying. That's the only time that you can use this skill. If you are adding two fractions, subtracting two fractions, dividing two fractions, it does not work. But as long as you're multiplying your two fractions, you can go ahead and use this. Now, ladies and gentlemen, the key to this is, once again, kind of like we did up top here, it's reducing a numerator with a denominator. As long as something in a numerator reduces with something in a denominator, we're good. So I've got 7296 times 42/54. If I were to take a look at this, one of the things that stands out to me first is the fact that both 72 and 54 are divisible by 9. And so I'm going to put a slash on both of these. And now when we reduce this, we like things that we're reducing on top to go further on top. We like things on bottom to go further down. So I'm going to divide these both by 9 now. 72 divided by 9 is 8. So I'm going to push that up a little bit so it doesn't mix in with the 72. And then 54 divided by 9 is 6. I'm going to push that down since it's on the bottom a little bit. Now from here, ladies and gentlemen, as long as it's a numerator with a denominator, you can reduce. So I know that 42 and 6 can both be divided by 6. So I'm going to divide this 42 and this 6 both by 6. 42 divided by 6 is 7. 6 divided by 6 is 1. At this point, I might say to myself, well, 96 is just 4 away from 100. And I know 4 goes into 100, so 4 must go into 96. So I should be able to reduce my 8 and my 96 both by 4. 8 reduced by 4 becomes a 2. 96 reduced by 4, well, it's 25 groups of 4 makes 100, so 24 groups of 4 must make 96. Oh, and if we look at this, the 2 and the 24 can reduce more. They can both be reduced by 2. 2 goes into itself once. 2 goes into 24 12 times. Now I got a 1 and a 7 up top. I got a 12 and a 1 on bottom. So 1s are as reduced as we can get. Once you get a 1, that number is done being reduced. So the only things we have left here that can be reduced are the 7 and the 12. So is there anything that goes into 7 that goes into 12? No, there isn't. which means that we have reduced this as much as we can. So if we go ahead and multiply, our answer will be completely reduced. So 1 times 7 is 7, and 12 times 1 is 12. This is 7/12. A whole lot easier than if we were to try to multiply these and then reduce it. All right. So ladies and gentlemen, another way that I might take a look at this is I might recognize that 72 hours is 3 days, 96 hours is 4 days. And so if you recognize that, you might actually reduce this down to 3/4. Now 42 and 54, we know that 6 goes into both of those. 6 goes into this 7 times. 6 goes into that 9 times. I got a 3 and a 7 on top. I got a 4 and a 9 on bottom. So I'm looking for something on top that reduces with something on bottom. Well, obviously 3 and 9 both reduce. 3 can be divided by 3, and it goes in once. 9 divided by 3 is 3. All right, so that 1 is completely done. So 7 is the only thing I can reduce now up top. So 7 and 3, can I reduce those? No. 7 and 4, can I reduce those? No. So we're ready to multiply. 1 times 7 is 7, and 4 times 3, hey, look at that. Comes out as 7/12 again. So ladies and gentlemen, as long as you reduce a numerator with a denominator, it doesn't matter what you reduce for first or what you reduce by. As long as you reduce everything, it'll come out the same each and every time. So, ladies and gentlemen, we're going to do a few practice problems from the book now. So if you'll flip your papers over. And so open up your books to page 172. Go ahead and pause the video if you need to. And here we go. A, so use the prime factorization to reduce each fraction. So for A, we're given 48 over 144, and it can be a good idea to make these full-size numbers here. With 48, I'll be honest, with 48, I like the factor tree because I know that 6 times 8 is 48, and then I know that 2 times 3 is 6. For 8, I know that 2 times 4, 2 is prime, is 8, and 4, 2 times 2 is 4. So we got 1, 2, 3, 4 2's. 1, 2, 3, 4 2's, and then a single 3. Now for 144, I also like the factor tree. I'll be honest, that's kind of my favorite. They're both good skills, but I do tend to like the factor tree better because I know that 144 is 12 times 12, and that makes this really easy now because 12 we know is 3 times 4. And I could just make this interesting. I could also say that it's 2 times 6 because why not? And then this 4, of course, is, whoops, not 4, excuse me, 2 times 2. And we know 6 is 2 times 3. So for this one, I have 1, 2, 3, 4 2's. But this time I have 2 3's instead of just 1. And so if we reduce this now, 2 on top, 2 on bottom, they both become 1's. 2 on top, 2 on bottom, they both become 1's. 2 on top, 2 on bottom, they both become 1's. 2 on top, 2 on bottom, they both become 1's. 3 on top, 3 on bottom, they both become 1's, and I'm out of pairs. Multiply everything up. 1 times 1 times 1 times 1 times 1 is 1. 1 times 1 times 1 times 1 times 1 times 3 is 3. 48 over 144 is really just 1/3. Let's skip a line and take a look at B. So for B, we have 90 over 324. 90 over 324. And so we're going to go ahead and reduce that using prime factorization. So for 90, Again, I like my factor tree because I know since it ends in 0, that's really just 9 times 10. And then once we know that that's 9 times 10, we can go ahead and split this up into 3 times 3, which we know are both prime. And then finally, 2 and 5 for 10. So put these in order for 90. So for 90, we have 2 times 3 times 3 times 5. And then for 324, this one might not be so obvious. This times this is 324. So this time, I'm going to go ahead and do the division by primes. And I'm looking at this and I see 3 plus 2 plus 4 is 9. So I know that 3 goes into this because 3 goes into 9. So let's do 3. 3 goes into itself once with nothing left over. So put a little 0 there. So that's really 0, 2, or just 2. Okay, so now 3 goes into 2. Well, not at all. So that means the 2 will be left over. So now that's a 24. 3 goes into 24 8 times, nice and evenly. All right, that's good. Well, this number is even, so let's divide it by 2. 2 we know goes into 10 5 times evenly, and into 8 4 times evenly. That's pretty nice. From here, probably the most obvious thing would be the fact that this is still even, so let's divide it by 2 again. 2 goes into 5 twice, but with 1 left over. So 2 goes into 14 7 times. Now 27 we should know is 3 times 9, and we know 3 goes into 9 3 times. So on bottom I've got 2 2's. I've got 1, 2, 3, 4 3's. 1, 2, 3, 4 3's. So I got to extend my fraction bar there a little bit. All right, and then we reduce. So 2 on top, 2 on bottom become 1's. A 3 on top and a 3 on bottom become 1's. A 3 on top and a 3 on bottom become 1's. And that's it. That's all we've got. So up top, 1 times 1 times 1 times 5 is 5. And on bottom, 1 times 2 is 2. Times 1 times 1 times 3 is 6. Times 3 again is 18. So there we go. Now, ladies and gentlemen, I'm going to show you another way that we can find our prime factorization. So using the work that we just did here, we can actually find our prime factorization really easily. So for this guy here, I'm going to copy down the problem, GCF of 90 and 324. If you take a look at your fraction, the reducing of your fraction here, just look at the numerator and look at what got crossed out. If we write down what got crossed out, 2, and then a 3, and another 3, if we put those together, so 2 times 3 is 6, times 3 is 18, that's actually our GCF. Because remember, when we divide by the GCF, it completely reduces the fraction. Well, if reducing this 2, 3, and 3 reduces the fraction, put them together, that's your GCF. So reducing the fraction using prime factorization can also be a trick for finding our GCF. All right, we're going to try a few more here. D, 5/8 times 3/10. And the thing that stands out to me first and foremost is I know 5 goes into both 5 and 10. 5 goes into itself once, 5 goes into 10 2 times. So 1's cannot be reduced any more than they are. So does 3 and 2 reduce? No. Does 3 and 8 reduce? No. So we got to multiply. 1 times 3 is 3, and 8 times 2 is 16. The reduced answer is 3/16. So for E, we have three fractions, 8/15 times 5/12 times 9/10. So, same idea here. Now, three fractions doesn't change anything. It's still going to be a numerator with a denominator. So again, 5s stand out to me just because they're easy. 5 goes into itself once, 5 goes into 15 three times. Now, could we reduce the 5 with the 10 instead? Absolutely. Absolutely. I just noticed the 15 first. Now, looking at this, what stands out to me next is maybe that 4 goes into 8 and 12. So 4 goes into 8 two times, 4 goes into 12 three times. Now, I see a lot of 3s, and that 9 catches my eye. I know that 3 and 9 can reduce. 3 goes into 9 three times. 3 goes into itself once. But then 3 and 3, remember we got the same thing on top and bottom, they both become 1s. They both reduce down to 1s. All right. So let's take stock of what we have. We got a 2, a 1, and a 1. So really it's only the 2 that can be reduced here. And then the 1, and the 10. So only the 10 can be reduced on bottom. So can we reduce a 10 and a 2? Yes, we can. 2 goes into itself once, and 2 goes into 10 five times. Now up top I got 1 times 1 times 1 is 1. And on bottom, 1 times 1 times 5 is 5. It's really just 1/5. And then we'll tackle F. I'm gonna skip an extra line here just because that came down so far. So since that came down so far, we'll skip that line. Come down here for F. I have 8/3. That's an improper fraction. So probably came from a mixed number. 6/7, and then 5/16. Now personally, the first thing that stands out to me is the 8 and the 16. I know that 8 goes into itself once, and 8 goes into 16 two times. The next thing that really catches my eye is the 3 and the 6. I know that 3 goes into 3 once, and 3 goes into 6 two times. All right, now obviously the 2 and the 2, remember if they're the same number, they reduce down to 1s. So looking, the only things that aren't 1s are my 5 and my 7. So do 5 and 7 reduce? No, they don't. So let's multiply. 1 times 1 times 5 is 5. 1 times 7 times 1 is 7. This is 5/7. And that, ladies and gentlemen, is the end of our lesson.